Okay, in this video we're going to be talking about a particular type of quadrilateral called a parallelogram. And a parallelogram is just a quadrilateral with both pairs of opposite sides parallel. So if this quadrilateral here, ABCD, is a parallelogram, then I could mark it like this. Since I know both pairs of opposite sides are parallel, I'll put a pair of parallel line marks on each pair of opposite sides. So this picture goes with the definition of a parallelogram. Both pairs of opposite sides are parallel. Now, we're going to be looking at 4 different parallelogram theorems, and each one of those is going to describe a particular property of a parallelogram. So, parallelogram theorem number 1 has to do with the opposite sides of a parallelogram. And parallelogram theorem number 1 says opposite sides of a parallelogram are congruent. So, once again, if quadrilateral ABCD is a parallelogram, then I know that side AB and side CD are congruent. Side BD and side AC are also congruent. And now I can use this property of parallelograms for solving certain types of problems. So I'm going to skip example number 1. Example number 2, in your notes it says solve for x and y. And I've got the sides labeled with these different expressions. And I can use the fact that opposite sides are congruent to set up my equation. So if I start with this one, I can say, well, 2x must be equal to 20, since these are opposite sides, so those sides are congruent. Divide those sides by 2, and I get x equals 10. I can also do the same thing here with this pair of opposite sides. 24 equals 3y. Divide both sides by 3, and I get y is equal to 8. And there are a few more examples in there under that parallelogram theorem. I want you to work those out on your own. Parallelogram theorem number 2. Parallelogram theorem number 2 has to do with opposite angles of a parallelogram. The opposite angles of a parallelogram are also congruent. So once again, if this quadrilateral ABCD is a parallelogram, then I know that angle A and angle C are congruent, and angle B and angle D are congruent. And once again, I can use this particular property of parallelograms to solve some types of problems. So for example, example number 5, it says find the measure of x, or find the value of x and the measure of angle D. Well, since I know opposite angles of a parallelogram are congruent, angle A and angle C are opposite. Since angle A is 120, angle C must be 120. And angle B and D are congruent, therefore angle B must be the same measure as angle D, which is 5x. Now I'm going to use something that I learned about the sum of all of the interior angles of a quadrilateral, which is that since it makes up 2 triangles, I know that the sum of all of the interior angles of this quadrilateral, a parallelogram, must be 360. So I can add up all 4 of these angles and set it equal to 360. So 120 plus 5x plus 120 plus 5x is equal to 360. So let's see, that's 240 plus 10x, and subtract 240 from both sides. And let me go up here. So that gives me 10x equals 120. And if I divide both sides by 10, then I get x equals 12. And the measure of angle D is going to be, since x is 12, 5 times 12 is going to be 60. Example number 6 says find x and y, and I think I'm missing some values here in angle 6. Yes, I am. So in example 6, I've got A is 125 degrees, B is 55 degrees, D is 3y plus 7, and C is 13x minus 5. So once again, I can use this property of parallelograms in my parallelogram theorem number 2. Since opposite angles are congruent, I've got two different equations that I can set up. I can set up this equation here with opposite angles A and C. 125 equals 13x minus 5. And then I've got this other equation I can set up here with opposite angles B and D. So 3y plus 7 equals 55. And then I can solve each one of those equations for x and y. And I'm going to leave that for you to finish, as well as the rest of these examples under parallelogram theorem number 2. Parallelogram theorem number 3. Parallelogram theorem number 3 has to do with not opposite angles, but consecutive angles, which is to say angles that are right next to each other around the parallelogram. Consecutive angles in a parallelogram are supplementary. And now hopefully this isn't too hard to see. Remember, if opposite sides of a parallelogram are parallel, if I extend this side out here, if I extend these lines out here, well, I've got two parallel lines cut by a transversal, and these two angles here and here would be same side interior angles. And if you remember, we have a theorem that says if two parallel lines are cut by a transversal, then same side interior angles are supplementary. And that's what this parallelogram theorem number 3 is referring to. So let's take a look at a couple of these examples, examples 7 and 8. So example number 7, I've got a parallelogram ABCD, and I've got this one measure here, angle A, and it says find the measures of angle B, angle C, and angle D. Well, since consecutive angles are supplementary, I know that angle A and angle D, which are consecutive angles, these must be supplementary, so 180 minus 115 is 65. Angle A and angle B are also consecutive angles, so this angle must also be 65. Plus, angle B is opposite angle D, so they must be congruent. Angle C is opposite angle A, so I know those two angles must be congruent from parallelogram theorem number 2. And here now I have angles B, angle C, and angle D. Example number 8, find x and the measure of angle C. So once again, I've got these two angles here are consecutive angles. According to my parallelogram theorem number 3, those angles must be supplementary, so 40 plus 12x minus 4 must equal 180 if those angles are supplementary. And let's see, combine like terms, 40 minus 4 is 36. Subtract 36 from both sides. 12x equals 444. So x is going to be equal to 12. Find x, find the measure of angle C. So the measure of angle C, I guess I could get this angle two different ways. Since I know what x is, I could plug that in and solve for the value of angle C. Also, since I know consecutive angles in a parallelogram are supplementary, I could just subtract 40 from 180, and I would know that this angle here must be 140 degrees. And again, there's some more examples there for you to solve on your own. Finally, our last parallelogram theorem number 4, and this theorem has to do with the diagonals of a parallelogram. The diagonals are just the lines drawn diagonally between the vertices, opposite vertices in a parallelogram. And I don't know how obvious this one is just from looking at a parallelogram, but parallelogram theorem number 4 has to do with the fact that the diagonals of a parallelogram cross right in the middle. That is to say, they bisect each other. So, parallelogram theorem number 4, the diagonals of a parallelogram bisect each other. So I know that for any parallelogram, the diagonals are always going to bisect each other. That is, this half of a diagonal is always going to be equal to that half. So I can now solve problems like, for example, number 12. So let's see. Segment DE equals 7x plus 2. So that's this segment DE. EB is 9x minus 6. So that's segment EB. I want to find the length of DB, which is the whole diagonal. Well, since I know from this parallelogram theorem number 4, the diagonals bisect each other, that means this piece of the diagonal is congruent to this piece. I can set up this equation, 7x plus 2 equals 9x minus 6, and now I can solve this equation. Let's see. Subtract 7x from each side. And let's add 6 to both sides. And that gives me 8 equals 2x. Divide both sides by 2, and I get x equals 4. So now I know what x is. It says to find the length of segment DB. So I want this whole segment here. So let's see. If I plug x in here, I can find segment DE. Segment DE is 7 times x plus 2. So that's 28 plus 2, which is 30. So DE is 30. Well, since these two segments are congruent, BE must be 30 also, which means segment DB must be equal to 30 plus 30, which is 60. So now I got segment DB. Now, you have some more examples to work in your notes, and I want you to try those on your own, and we're going to take a look at those tomorrow in class.